Okay, so let's take a look at a sequence that we know is arithmetic. And so if you look at the pattern here, you can probably see it pretty quickly that we're just going, plus 6 over and over. So this one's arithmetic. And oftentimes you're going to be asked to find a rule that describes mathematically what's this pattern that's happening. And so rules can be written in a couple ways. One way is something called an explicit rule. Like if I was to ask, let's say the sequence kept on going all the way out to the 53rd term. The 53rd number that appeared in this sequence would be what? Well, that'd be kind of tricky. I'd have to keep adding 6 over and over, and especially if I said like, what's the 6,000th term or something like that. So by developing a rule, it really gives us a shortcut to find any term in the sequence really quickly. And so let me walk you through how to do that. One thing that you want to be looking for, there's a couple methods to do this, but here's one method that I like. I'll start by making a table, and I could just say, well, if I call n any number in my sequence, so and by number I mean what number term. So the 8 is my first term, the 14 is my second term, third term, fourth term, and so on. So the first term was an 8, the second term was a 14, third was a 20. Okay, and so if we can almost think of this table as an input-output. So if my input was n, I could say that f of n is my output. That's the number that is actually a part of the sequence. And so what I want to develop by making an explicit rule is I want a shortcut that basically says, hey, f of n is going to equal, and I can just find it really quickly. If I kept this sequence going way out here to any number I want, n, let's say that 53rd term, well then f of n would be the output for it. So how do I find that? And we can actually use the pattern that's been happening here, right? Well, plus 6, plus 6. That's going to be part of our rule. And one method is to think of what if there had been a zero term? What if this sequence went back to like an original zero value? What would have gone here? If I'm going plus 6 this way, I could just continue the pattern backwards, subtract 6, and I'd have to be at 2. So if I took 2 and I added 6, right, it would continue this pattern. And this zero value can be important. It's really a nice shortcut when you're writing a rule. So here's really what I've got happening. 2 plus 6 plus 6 plus 6 plus 6. That's what's happening. I've got 2 here plus 6 over and over and over. And when you've got repeated addition, that's really the definition of what multiplication is. When you repeatedly add or repeatedly subtract, that's multiplication. So I can write this a little bit more mathematically. I can say 2 is getting repeated, or 2 plus 6, and plus 6 repeats n number of times. So, like for example, when I'm at 3, how many times has that plus 6 happened? 1, 2, 3 times to get here. When I'm at 5, how many times has the plus 6 happened? 1, 2, 3, 4, 5 times. When I want n, how many times will that plus 6 have happened? Well, plus 6 will have happened n times to get me to n. So this rule will let me kind of skip around on this table and find any number n on the sequence. And more often you'll see it written like this. When you get to some higher math, you'll usually see terms that have an n or higher exponents written first. So we can actually just switch these two and write our 6n first and our positive 2 second. Really the same rule. And that fits the pattern you might have seen before. You might have noticed these are a lot like linear equations. It's almost like mx plus b, where b is your zero value. Anyway, there's a lot of similarities. But this is our explicit rule. And to go back to our original question, if I said, what's the 53rd term? I can say, well, f of 53 is going to be what? Well, I'll take 6n. In this case, I want 53, so 6 times 53 plus 2, and you can multiply that out, and you've got your solution here, f of 53. We're at 320. Now, I mentioned using the zero term was one method of doing that, but what if you didn't know the zero term, or what if this was, hard to find, or you're having a bad day and didn't want to think about it? There are other ways that you can do this. Another way to do it, to write the same rule, just kind of a different format and another way to think about it. Instead of needing to know that zero term, let's use the first term here. If I want to get to this from this 8 to the 20, well, how many times did I have to add 6? If I want to get to that third term, I had to do it twice. Or if I wanted to get to the fifth term, I'd have to do it 4 times. So it's really one less. There's 4 of these to get to the fifth term. There's 1 of these to get to the second term. So the number of times this has happened is 1 less than the actual number. And so I can write, instead of putting 6 repeating n number of times, I can say plus 6 is getting repeated n minus 1 number of times. It's almost like I'm saying, let's ignore this one. Instead of there being 3 of them, it's 1 less than that. So that plus 6 is getting repeated 1 less if I start at 8. And so instead of using my 0 value, I'm going to just use my f of 1, my first term, which is going to be plus 8. And so this rule, also an explicit rule, is equivalent to this one. If I were to distribute this out, I'd get 6n minus 6 plus 8, which is 6n plus 2, which is the same thing. And that also works wherever I want to start in the sequence. If I want to start at the 4th term in the sequence, I can say, okay, well, f of n is going to equal plus 6 getting repeated over and over. I'm going to say n minus 4 number of times, since I'm starting with that 4th term, plus 26. So if I start at the 4th term, I'll put n happens to repeat n minus 4 times, and then put the 4th term in the sequence there. And if I distribute this out, it becomes equivalent to this also. And this is similar, if you want to relate it back to some algebra that you might have seen. If I called this my y and my slope, and this is also a y value, I could call that my y1. It's almost like I've got y minus y1 m x minus x1. So I've got my point slope formula really doing the same thing this is doing. It's just kind of how we write it when we're talking about sequences. So whichever method you are more comfortable with, if you like, I'll just find that 0 term and write it this way. Or if no, I don't even want to think about it. I'm just going to write my first term and say plus 6 happened n minus 1 times. That's fine also. These become equivalent formulas.